Moving into the second decade of the 21st century, we face growing challenges which require us to respond with innovative and unique solutions. Our energy needs continue to grow. At the same time, we must reduce our emissions levels. We must reduce the environmental and economic costs of providing and maintaining landfill sites. One company has addressed all of these issues with a stunningly efficient and effective solution. The company is Premier Green Energy. The solution is the Prima 3000. The Prima 3000 takes various fuel source feeds and, using a process of pyrolysis, produces a number of useful byproducts, including a large volume of high calorific syngas, which is ideal for powering a gas engine for the clean and efficient generation of electricity. The Prima 3000 can operate efficiently on a highly diverse range of fuels, including the following examples: refuse-derived fuel, also known as municipal solid waste, wood chip, biofuels and rejected crops, sewage sludge and industrial waste, shredded tires. The chosen fuel source is loaded into a hopper. Each load is weighed individually before it enters the loading hopper, allowing for accurate recording of the amount of fuel used. A conveyor system takes the fuel up to the compactor hopper. Here, the fuel is compressed into pellets by hydraulic rams to exclude air containing oxygen. The fuel pellets then enter the infeed hopper, from where they are fed via a scroll into the main retort. Here in the main retort, in the absence of oxygen, pyrolysis of the fuel takes place at 700 degrees centigrade. Heat and fuel in the presence of oxygen will burn. Heat and fuel alone produce pyrolysis. The great advantage of pyrolysis is that because the oxygen has been excluded, the heat and the chlorine present in the fuel cannot produce harmful dioxins. The syngas produced in the Prima 3000 by the pyrolysis of the fuel is taken from the retort and is quenched, which is the first step in conditioning the gas to produce a clean product with a high calorific value. The gas is then put through a wash tower, where it is washed in a medium pressure gas wash system. In the next step, the gas passes through a dual tower gas absorption system, where it is scrubbed to produce a clean gas of high calorific value. In the case of this demonstration unit, the clean gas is burned off in a flare mechanism. From biomass fuel, the Prima 3000 produces gas with a typical calorific value of between 16 and 20 megajoules per meter cubed. From refuse-derived fuel, the Prima 3000 produces gas with a typical calorific value of between 20 and 24 megajoules per meter cubed. The second product of the Prima 3000's pyrolysis process is char. Char is a combination of carbon and ash. The char exits the retort and travels along a char cooling scroll to a char storage tank, from where it is fed via 2 scrolls to fans, which deliver the material to the thermal oxidizer unit. The speed of the 2 scrolls before the fans controls the volume of char being sent to feed the thermal oxidizer. Inside the thermal oxidizer, 4 straff fans help to generate temperatures of 1250 degrees centigrade. The hot flue gases generated from the combustion of the char are circulated through the outside skin of the retort, where the heat radiates through the walls and into the fuel, which causes pyrolysis to happen, producing syngas and char. The Prima 3000 utilizes a very efficient process and has a low parasitic load. The hot gases from the thermal oxidizer which have heated the retort are passed on to a heat recovery system, which can generate hot water or steam, depending on what is required. This system can supply hot water to local houses and businesses. On this Prima 3000 demonstration system, we see that the heat is being dissipated through a fin cooling system. The hot gas is then passed through a ceramic dust collection system before exiting via a chimney. The chimney is monitored and certified to ensure that the system is working properly. The final byproduct of the Prima 3000 pyrolysis process is a vitrified inert slag, produced when the char is sent to the thermal oxidizer. It is a fusion of ash and any inert materials, and it can be used in building materials and in road building. The control room for the Prima 3000 is a fully automated SCADA-based control system. All pressures and temperatures are constantly monitored and adjusted to ensure that the plant runs at maximum efficiency. The Premier Green Energy Prima 3000 is capable of converting 3 tons of fuel per hour into cheap, clean electricity. Prima 3000 from Premier Green Energy is high in efficiency and low on carbon footprint. Premier Green Energy, powering a better future.